Okay, great. So, hello everyone. Today we'll present ChatPharo, which is an open architecture for understanding how to talk live with LLMs. First of all, I would like to give a special thanks for these people, Benoit, Casper, Valentin, Chris, Balcha, and our GSOC student, Rajar. This is a project for GSOC student for 2025. So just a small introduction. So I am a PhD student working on the completion engine inside Pharo. I am an artificial intelligence engineer, and I am interested in supporting LLMs for the low resources languages and how to gain more in terms of code generation, especially for inside Pharo using LLMs. So a small introduction of the large language models, the LLMs. Some of you knows and some of you don't know what's an LLM. So I would like to introduce what's an LLMs. LLMs are neural networks with billions of parameters that are trained on large-scale data. So it can understand, generate human text languages. And of course, with fine-tuning tasks, we could let's say, do some specific tasks like code generation, context learning, and reasoning. So, okay, we know what's an LLM. We know how to generate text, but how it actually works for generating code. So, it's the same thing as text. We give him text because code is a text, but the interesting part from inside the code, it's the patterns matching. We don't need a text, we need a code. So if there is no pattern matching, he won't know that this is a code, so I need to synclize the code. There is a if, after the if there is a space, otherwise. Okay, so why? Of course, we need a lot of data for the text or the code. We need a lot of data for the LLM to be able to generate code. But there is an interesting question which is related to why the LLM are better for Java, JavaScript, and other languages, and let's say are not very good for Pharo. Let's say the harsh truth that there is a lot of data on let's say the internet related to Java and JavaScript. Yesterday I found out that there is like 1,000 questions that have been asked about Pharo on Stack Overflow, comparing to the, let's say, Java and JavaScript, which might have thousands or hundreds of thousands related to these languages, as Java and JavaScript, and which is really important because when you are trying to train an LLM, it's not just a code. You don't give the whole code. You need more than code. You need how to fix bugs. You need an interaction between a human and a human. This is wrong, this is correct, to be able to give let's say, the reasoning for the LLM. Okay, we know what's an LLM. We know how to generate code for LLM. But the interesting part for this presentation is how to generate code for the low resources languages. Let's take Pharo as a use case. I read an article for Alessandro about the fine-tuning of, let's say, about the code generation for the low resources languages. And he found out that there is multiple methodology to understand and to, let's say, do the code generation for the low resources languages. So the first methodology that he found out that we could fine-tune a small model, let's say 1 billion parameter model, which is called as small languages. We could fine-tune this model because as the data are able to update the whole weights of the model, so we would have, let's say, a good model for the code generation task. If we want to go up higher with, let's say, parameters, we want more, let's say, examples, which is called few-shot prompts, yeah, few-shot learning, which is during the training or during the fine-tuning, we pass to the LLM small examples that of Pharo code, if we are trying to generate Pharo code or train a Pharo LLM. And finally, Alessandro found that if we take big model, like more than 33 billion parameters, well, that's not a good idea, because the data won't able to update the whole parameter of the model. So it's not a good idea. Anyways, so I forgot. So anyway, why the LLM? Now we know how to generate. We know what's an LLM. We know how to generate a code. We know how to generate code for a low resources languages, but we need to understand how to generate code for Pharo specifically, because Pharo has, let's say, multiple features that it could be interested to think differently in terms of implementation of the LLM. First, Pharo, well, the known rule that there is not a lot of data. There is a GitHub repository, there is other GitHub repository. It's not a lot. And the problem is that when you are training an LLM, you need to annotate the code. It's not just, yeah, I have the code, do whatever you want, and I will get the model. No, it's not like that. You need annotator to understand this task is related for this code, etc. So we need data, which doesn't exist for now. I don't know if the private company have data, but there is no publicly available data. And the second part, or the second point, is about Pharo is very dynamic, meaning that today there is this class called ChatPharo. Tomorrow it might be renamed as CP, which is not beneficial when you are training a model, because once you train a model, you freeze this model on this specific code. You change the code, you need to retrain the model. So that's why there is multiple methodology to understand how, and let's say to give the capacity of the model to integrate with these specific problems. For example, we could use the retrieval augmented generation, the RAG, for searching. Let's say we create a small data. We train this model on this data, and then we give the whole image or the whole code base. And then he will search, understand what's the question, and search inside this, this code base. We could also, as I said, we could fine-tune using examples. But what I want to discuss and what I want to focus is the tool calling, which is which is very important for this presentation. So what's a tool calling? So a tool calling, it's let's say in a technical way, it's just a method inside your class that could be executed. First, it's invoked from the model and executed from the image. The model will invoke this tool, execute, fetch information, and return this information to the assistant. I will give an example. So this is a small example of a tool calling from Pharo. We have model here, the name of the model. We have the system prompt. You are an AI coding assistant inside the user's Pharo image. And we have my question, the user's question. Which packets in my image mention HTTP networking? So this is what's sent as sending prompt to the model. What the interaction between the model and the image, the model will understand that I don't know this question, I don't know the answer of this question, I'm supposed to invoke a tool inside the image to give me this information. So he will create, let's say, a new node inside the JSON file. The content is null because he's expecting the content from the image. And he is calling the function getPackages, which has non-argument because also he is expecting argument from the image. And once it's invoked from the inside the image, the tool will be executed and getting information. The tool call ID, it's this ID. The packages, he, as a tool, of course, execute this tool, fetch the information. So he got like the NeoJSON, the AI ChatPharo, and the HTTP package. Those are related to the implementation for the question asked. And it will be resent to the assistant. The assistant will generate a better response. In this case, I found 3 packages, and it will return to the user as a prompt answer. So now we know what's an LLM. We know how to generate code, specifically for the low resources languages. We know what's the tool calling. What is ChatPharo? ChatPharo, it's not just, let's say, interface inside Pharo that allows you to discuss with LLMs. It's more than that. It's giving you live information for your image, meaning that if your package exists on your image, and it's not on internet, it's not on, I don't know, GitHub or something like that, he's capable of fetching this package because he's getting information from your image. Now, I know the security and the experts, it's not very well appreciated to give information for Gemini and other APIs, but there is like local models that could be beneficial to understand and to use them, like Olama. It can be beneficial to understand how the local model behave, more specifically because local models are small, meaning that it's not big as the Gemini model, for example, or GPT-4o, for example. So this is a small example. Sorry, I didn't have a live demo for technical issues, but this is a small UI example of what's ChatPharo and what, let's say, the user interface of ChatPharo. I would like to mention here that this temporary ChatPharo, it's without any context, meaning that there is just one single tool that could be invoked from the model, which is Open Playground. For example, if you ask him to generate, let's say, hello world, he will understand that I'm supposed, as a model, to generate code and pass it in the playground. So we'll open Playground with you and paste the code generated. And the interesting part of ChatPharo, it's the implementation inside the system browser. I know that it's not very well presented, but so yeah. Let's take this example as, let's say this example. When you are selecting AI ChatPharo, the model will know at online that you are in AI ChatPharo, the package. So if you ask him here the question, what are the classes and the subclasses, and explain to me what are these classes, he will know because he is fetching this package, this specific package. And of course, here, if you are asking him about, so if you select ChatPharo message and you select this tab, so he will see that you are browsing inside the classes, not inside the package. So he won't return to the package. Now, I would like to present you a successful case. There is successful and failed case, just to let you know. There is a successful case. I open Russell chart, the package. I ask him to generate code to draw inside Russell. He read all classes, and he tell me inside the response that this package RS composite chart class combine different plots and decoration, and here's the general outline of how to do it. He explained inside the prompt, he explained what are the classes, what are the methods inside it. He understand it, and he give me this response. No, now there is an important question to ask, which is related to why is this scenario is successful, which is important as a scenario. The question is, what kind of information should I give the model to give me this good code, or to have a valuable response? So the answer for this question, I don't know if, no, it's not here. So the answer for this question is very related to, first, how you ask the question, and secondly, what are the type of the tools that are implemented inside ChatPharo. For example, the tools that currently implemented are general tools, meaning that he can fetch the packages, he can read the classes, he can read the comment of the classes, the messages, etc. He can describe the package, but he's not capable of giving you example of how to create a presenter in Spec, because there is no tools. The tools are created by a human. It's not magic. So, as Casper experiment about the class comment. For example, if I want to know comments about this class, I would like to know also what are the users of this class. It could be beneficial as information for the model. Good. And another example, it could be interesting to see how we can, or could we, implement a tool that search inside the example of Pharo. We have a lot of example inside Spec. If we could pass it as, let's say, tool inside ChatPharo, it could be beneficial as information for the model. Now, yeah, you would ask yourself, okay, why would I create one single tool that fetches the whole image? You could, but it's not beneficial, because you are fetching a lot of information for the model, and the model won't see the whole code. Won't see the whole code. The model are lazy. He will see just the first 2 lines and the end 2 lines. That's it. If you ask more questions, he will search inside the code and inside the text or the prompt that you pass it. So for example, the Spec part, we could add a tool that execute or search or understand more how the layout function, another tool that execute or understand how the presenter function. I should. So what I want to say here that it's not a good idea to fetch a whole code. It's not a good idea to fetch a whole code. First, it depends really on the user question. If the user is biased in his question, the model and the tool are not beneficial. If the user are very specific in question, so in this case, the model will understand the question, will be able to execute the tool, and finally, he will be able to get a better response and a better version for the code. Now, as I said, why there is fail cases. For example, here, I asked him the same question, how to draw a chart inside Russell. He told me, okay, sorry, I cannot help you with this because I like the ability to work with Russell, which is wrong. If I give him here the possibility of going inside the package and fetching the classes inside the package, he will be able to answer this question. Now, if I ask this question in, let's say, in a different way, like how I can create a graph in Pharo, he won't know it, because there is no tools that allows you to relate that creating a chart inside Pharo is related to Russell, and then Russell, I'm supposed to go inside the package, fetch the classes, etc. Yes, so the point, as I said, from the tool calling is, the point is it's very clear. It's to fetch information from your image. There is no hallucination because you are passing information from the image to the model. You are getting a live information, which is a priority for the model because he's expecting argument or content from from the image. And a future fork for this project for ChatPharo, of course, I would like to reduce the hallucination first, and I mean like enhancement in terms of understanding the question of the user. Of course, it could. It's very how to say. It's very interesting to see how we could reduce the hallucination through implementing more and more tools. Of course, with the implementation of the pipeline through the tools. It's not like, hey, model, I have these tools, and yeah, go do whatever you want. It's not like that. I would like to have a pipeline when the tools are executed first, and how the tools are executed, and how much data they are going inside the code. Otherwise, there will be a lot of data. And if you have ideas for scenarios, it could be very beneficial. Do not hesitate to contact me. I have a lot of ideas for Pharo, especially inside the debugger, the refactoring engine. I'm working with Balsha with this project, so if you have any idea or any, let's say, futures that could be beneficial for you, don't hesitate to ask me. Small summary for the ChatPharo. ChatPharo, it's not just an interface; it's a conversational assistant integrated in your Pharo image. He's fetching live and real data from your image. And finally, which is the most important point, right amount of data, meaning valuable response. But does it mean a correct response? And thank you all. I don't know how much. Yes, question. Ah. Yes. For you mean for inside the system browser? Yes. So for the system browser, when you ask her for draw a chart and you select this package, which is you saw it's Russell chart. So I, as a user, I know that there is something interesting inside this package. So it's just one single tool, or I think multiple tools. But anyway, the point is he's fetching information from this package, meaning that the classes are fetched, the messages are fetched, and the comments are fetched.
Ah, so it doesn't have an additional tool already prepared to sort of interface with the AI. It actually understood by reading the code what it could do, and then...
Yes.
Nice.
Yes.
Okay, thank you.
Any other questions?
Hi. You mentioned at the beginning of your talk that you wanted to investigate fine-tuning, right? And that fine-tuning of large model is actually like super hard to do, blah, blah, blah. But have you investigated like fine-tuning using what they call LoRa model? I don't know if you are aware of what this is.
I don't have very information about how the, let's say, for this specific task. But the point of the paper, it was really about how are the methodologies to experiment on the low resources languages.
Yeah, that's why I bring this subject, because with I think it's called LoRa, fine-tuning. It's you bring a super tiny model right next to the big model that you have. So, for instance, Llama 3, and you will add a tiny model next to it, and the answer from Llama 3 will go through this tiny model, and you are fine-tuning the tiny model instead of the big one. And so you can fine-tune it with a specific task for Pharo, for instance, because you would require way less data to do the fine-tuning this way. So it could be something that you could use as well.
Yeah, just a comment about tiny models. It's just I have a data, I have a model. There is no model between them.
Yes,
it's
you have
a standard fine tuning.
Okay, I will talk to you later, maybe. Yes. More suggestion.
Is there any questions left? Well, thank you, Omar.
Thank you all.